Thank you, Amanda.
Thank you very much, Godfrey. Apologies from KZN. I hope you can all hear me and that I'm audible. Thank you for joining today's engineering webinar on artificial intelligence. My name is Amanda Masondo Mkhize, and I'll be facilitating this session. As engineers, we're increasingly called to interrogate AI systems into traditional workflows, from model-based designs and real-time systems optimizations to machine learning applications in asset management and predictive analysis. The convergence of AI and engineering is not just to enhance our operational efficiencies, but to redefine how infrastructure, manufacturing, and technology solutions are conceived and delivered. Today's webinar, I bring you two experts who are actively applying AI across various engineering domains. They will share implementations and strategies and lesson learned from projects and the intersections of computation and engineering innovation. Please feel free to post your questions and answers in the chat during the session, and we'll address them during the question and answer segment at the end. To begin our presentations, our webinar today, it's my pleasure to introduce to you our first speaker, Rozina. Rozina Myoya is a multidisciplinary professional with a master's degree in both transport engineering and data science. With over 6 years of experience across infrastructure design, mobility systems, and machine learning, she thrives at the intersection of engineering and analytics. Rozina has led transport research projects, conducted AI-driven public transport research, and contributed to multilingual NLP for African languages. Her career spans roles from consulting engineering, data science, underpinned by a passion for solving complex mobility and societal challenges through data-driven innovation. She's committed to building equitable, efficient systems that serve people and our planet. Rozina, the floor is yours. Thank you.
Thank you. Thank you so much. Thank you guys for having me. Today I'll be presenting, as they said, on the intersection of transport engineering and data science. The work I'll be sharing today is based on research that I conducted at the University of Pretoria. So I'll walk you through how this research evolved over the years. I'll highlight how the data science aspect was applied within the transport engineering context. And then we can explore future possibilities, especially in light of the rapid advancements in artificial intelligence tools. Cool. So I'll start with a timeline of my research career, highlighting each milestone in each phase and how each phase of my research is essentially connected to the other. So if we look at phase one of my research, which focused mostly on your traditional engineering, civil engineering, where I focused on how the gap size on platform train interface occurrences affect the safety of passengers within metro rail train stations. So you've probably seen the sign, "Mind the gap," at train stations. Well, those signs are there for a reason. So at the time of my research, the gap-related accidents and incidents accounted for the highest number of passenger-related safety occurrences on train stations. And this was according to the Railway Safety Regulator. So the goal was then to develop a risk profiling method that considered all of the station-related factors that contributed to these accidents happening. And with this data, we could then propose targeted interventions to PRASA so that they can implement them with the aim of either reducing or ideally eliminating these accidents. Simple, straightforward, but it got very complicated as we went along with the research. So like I said, initially, looking at just how the gap size affects safety incidents, we looked at how we could monitor this gap size change and basically implement proactive maintenance. So the change in the gap size happens because as time goes by, the track in the station deteriorates at a specific rate. So the idea was to develop a system which could monitor this deterioration rate and then essentially trigger maintenance when it's needed. So as I was developing this system and visiting some stations, it became clear to me that other issues could also be contributing to this platform train interface accidents. So for example, an unreliable train schedule led to severe overcrowding at stations. where you would find that people would have to rush to get into the train because you never know when the next train is coming. And if you add a large gap into that mix, you find that the risk of a PTI incident only increases. If you think of the culture of train surfing, or as they refer to it, stuff riding, where people would essentially travel or ride the train outside of the train. So, what happens in these circumstances is that you find a lot of people would fall off the train, fall onto the platform, and in some instances, they could even fall into the gap if the gap is big enough. And some of these incidents would end in a fatality. If you think of the harassment that women experience in some of these stations, you hear a lot of stories where women complain about the harassment they've faced. And to make it worse, there's never any kind of effective response from the people who are supposed to ensure their safety within the systems. Something also as simple as the availability of clean toilets in stations was a major pain point for commuters. So that's when I realized that to design or to try and improve a public transport service, you can't look at it just strictly from a structural or technical perspective. You need a more holistic view, and this view has to be centered on the user experience. So that then raised the question, how can I capture meaningful data on the user experience? And that question is essentially the foundation of phase two of my research. So, phase two of my research, that's when I went into the data science space. So, after recognizing that structural improvements alone were not enough, I turned to data science to better understand the user experience. So, the question then became, how can we collect, process, and analyze commuter feedback at scale and in real time? Data science opened up new possibilities like mining social media conversations, applying natural language processing to multilingual data sets, and uncovering sentiment trends that traditional surveys often missed. So, this phase marked a shift within my research, which moved from just engineering physical infrastructure to engineering insights by using data to amplify the commuter voices and guide more human centered transport solutions. So the research in phase two involved mining commuter opinion on public transport using social media data, specifically data from X, which was formerly known as Twitter. So the study looked at three major transport hubs. I looked at Nairobi in Kenya, Dar es Salaam in Tanzania, and Johannesburg, South Africa. So we focused on the three dominant modes of transport in these cities. So looking at minibus taxis in Nairobi, and then buses in Dar es Salaam, and train services in South Africa. So a key challenge was the linguistic diversity within our data set. So commuters in these regions often shared their experiences in languages such as Swahili, isiZulu, and Setswana, and not just in English. So to address this, we had to use multilingual opinion mining techniques to capture and interpret this sentiment across the multiple languages. So the aim was to gain deeper insight into the public transport user experience by uncovering the recurring pain points and proposing meaningful solutions that go beyond infrastructure alone. So if we look at the graph, this shows the language distribution within our dataset. We used a language identification tool called Frank, which is a library that's available in Python. So as you can see, most of the posts were in English, which was about 37.3%, followed by English Swahili mixes, which is about 28.9%, and English Setswana mixes, which was 15.2%. And we also had a small portion of pure Setswana and Swahili, and isiZulu made up about 0.3%. So that is essentially the landscape of the data we were working with. Now, this slide shows the process of feature extraction. So this was part of our exploratory data analysis, where in natural language processing, feature extraction usually refers to a process of transforming your raw text data into structured features that machine learning models can interpret and analyze more effectively. So in this case, we use the word-to-vec model in Python to generate word embeddings within our dataset, which are essentially the numerical vector representation of words that capture the semantic meaning of that word within the dataset. So then after that, we applied k-means clustering to group the similar embeddings together. allowing us to identify the meaningful patterns and hopefully derive the underlying themes within the data. So if, for example, if we look at the Kenyan data set, the keyword from one of the classes is madawa, which essentially translates to drugs in Swahili. And all the tweets related to this theme revealed concerns about passengers being drugged in minibus taxis, and this highlighted a serious safety concern within the space of commuters within the Nairobi dataset. And then in the Tanzanian dataset, we had the word, for example, umeongezeka, which translates to has increased, which frequently appeared in discussions about fare hikes, and this reflected the commuter frustration around the rising transport costs. In the South African dataset, we saw the term vandalism repeated frequently, and this pointed to frequent mentions of damage to transport infrastructure, especially within the railway space. So after the feature extraction, we moved on to try and identify the most suitable pre-trained language models for sentiment classification of the commuter data. So we needed models that had been pre-trained on languages that were present within our data set. So specifically looking at English, Swahili, isiZulu, and Setswana. The PLMs we selected were AfriBerta, AfroXLMR, AfroLM, and PureBarta. Each of these models offered varying levels of support for African languages, making them strong candidates for our multilingual sentiment analysis. For more details on all of this, with the training process and testing process, I've added a link to the full publication at the end of this presentation. So finally, we did the sentiment classification and we segmented the source data based on both languages as well as the main themes identified during the feature extraction. So each segment was then processed using the most appropriate pre-trained language model, specifically for that language, and then allowing us to generate predicted sentiment classifications for each theme and each language group. So we felt that this approach ensured more accurate and more context-aware sentiment analysis across our multilingual dataset. Overall, the sentiment expressed by commuters towards public transport was predominantly negative, with key concerns centered around safety risks, fare increases, as well as the poor quality of service provided by government institutions. So for a deeper dive again into the research findings and methodology, please feel free to read our published paper. I've also included those details at the end of this presentation. So this brings me to phase 3 of my research journey. And in this current phase, I'm exploring ways to refine the analysis process from phase 1 by applying modern machine learning tools that are now available to me. So for example, back in phase 1, the only available data we had on the user experience came from the Railway Safety Regulator, which was based on the PTI incident descriptions that were recorded by PRASA. So at the time, I wasn't aware of any machine learning tools that could extract deeper insights from this kind of qualitative data. And the method I used was predominantly keyword searches, which allowed me to manually categorize the PTI occurrences into 3 main causes. So these 3 main causes were first, moving train, which referred to the occurrence of commuters who fell while trying to alight or board, a moving train. We had overcrowding, which indicated occurrences as a result of pushing and shoving due to excessive crowding during boarding and exiting the train. And lastly, we had staff riding, which were occurrences related to train surfing or riding on the outside of the train. But now with the availability of more NLP tools, we're able to extract much richer themes and patterns from that same data. So for example, using the Claude 3.5 Sonnet model, I fed the PTI occurrence descriptions to that language model and prompted it to categorize the underlying causes of the incidents. So compared to my earlier keyword-based method, the LLM produced a more robust and nuanced category list, and it captured a lot more of the subtleties that I would have otherwise missed. So to put it into perspective, the manual keyword search approach took me about a week to complete, especially because I had to validate the findings that I had, while the LLM-based method took just over a day, and that also included the validation process. So this clearly demonstrates the efficiency and depth that some of these AI tools can bring to transport research workflows by not just saving time, but also enriching the insights we can extract from the existing data. In the next step of this journey, I hope to develop a tool that can provide a more holistic profile of a transport service. So in this case, say, for example, a train station, one that can combine both the infrastructural monitoring as well as the commuter sentiment analysis. So imagine a tool running in real time that not only diagnoses the issues that as they rise, but also prescribes targeted solutions. So such a tool could be used for example, incident detection, where analyzing real-time public sentiment, we can identify and respond to safety and operational incidents more effectively. Secondly, research such as this could help address the information gap for service providers, giving them actionable insights about our experiences and expectations. And finally, such research lays the groundwork to inform future public transport initiatives, promoting more user centered design that prioritizes safety, efficiency, and responsiveness to real commuter needs. So, in conclusion, we have seen that transport safety issues are complex and multifaceted. As you saw initially, my research was focused on trying to see how the infrastructure affects the safety of passengers within train stations, only to find that also other systemic issues like overcrowding, unreliable scheduling, and an unsafe commuter environment also contributes to the risk of passenger safety within stations. Secondly, looking at the user experience is central to transport effectiveness. So a purely structural lens has proven to be insufficient. So real commuter voices, especially women and vulnerable groups, must be part of the data landscape to shape more inclusive transport systems. And a tool like multilingual NLP and social media mining are powerful. So mining public sentiment across languages like Swahili, isiZulu, and Setswana provided more insight into the commuter pain points and showed us that issues such as fare hikes and safety concerns are massive aspects to consider while designing transport systems. Then you have AI and LLMs significantly, AI and LLM tools significantly improve analysis. So you look at tools such as Claude, which drastically reduced the analysis time and revealed more nuanced patterns compared to your manual keyword methods. And as we saw, there's real potential for real-time intelligent monitoring systems where we could combine commuter sentiment with infrastructure data and open doors to tools that not only detect issues, but recommend proactive solutions, which could ultimately enable safer, more responsive transport. Lastly, user-centered research drives smarter transport planning. So these insights help service providers close information gaps and design future systems with a greater focus on safety, equity, and commuter needs. With all this in mind, I'd like to end by highlighting the true significance of public transport within a country. It is the lifeline of most nations and plays a pivotal role in empowering people and enhancing their quality of life. So imagine a future within the continent where people are not captive to public transport, but choose it willingly and confidently as their preferred mode of transport. Perhaps this is not just a dream, but actually a design challenge, an invitation to shape societies that prioritize efficiency, accessibility, and sustainability through the way we move. Thank you. Any questions?
Thank you so much, Rozina, for your presentation. Indeed, we can see the future is bright. Rozina, I would like us to have questions and answers at the end of the session. So I'd like us to allow our next speaker to do the presentation, and then we'll take all the questions and answers at the end. To all our guests, please feel free to post your questions and answers in the Q&A box or in the chat box, and we'll address them at the end. Without further ado, allow me to introduce our next speaker. Ever since he began dismantling a toy or cars to see what made them roll, One question has driven him: how can we build smarter? Today, as a pavement engineer at ROMH Consulting, he designs and analyzes airfield and highway pavements that must withstand heavy loads and harsh climates. He combines environmental fluids, mechanics, data analytics, and code to deliver robust, cost-effective solutions. During his time at NACO, he integrated aircraft transponder data into pavement traffic forecast, built a computer vision model that cut image processing time by more than 90%, and automated 3D visualizations in Revit. Initiatives that freed hundreds of engineering hours and underscored the value of letting machine handle the grunt work. He is completing an ME in pavement engineering at Stellenbosch University and adding to his MSc in coastal engineering from UKZN. He was a finalist for the CISA Young Engineer Award and a speaker on the AI construction, and he remains focused on making infrastructure more resilient, intelligent, and sustainable. Ladies and gentlemen, Dawit, the floor is yours.
Thank you. Am I audible?
Yes, you are. Thank you.
Okay, thank you. That was a very generous introduction written by me. Thank you very much for the opportunity to speak about this topic. I think this is something that has been on the forefront of everyone's mind in the past few years. I will be speaking about the engineering workflow automation and incorporation of large language models into engineering workflow generally. My name is Dawit Seyoum. I have completed my first master's and BSc at the University of KwaZulu-Natal in civil engineering, and I am now completing my Master of Engineering and Civil Engineering at Stellenbosch University. I am very well adversed in programming in multiple languages, with the main one being Python. I have worked as an analyst at Nedbank Corporate Investment Banking and worked as a civil engineer at Netherlands Airport Consulting, and now I am currently working as a civil engineer at ROMH Consulting. Now, before we get into the serious stuff, just a quick fun memes that that are quite serious. The AI landscape currently, it's quite a bit of a cesspool of products that are all AI powered, with very little concern about the implications on society and thinking capabilities of people. To speak about the satire of this situation, I have asked GPT to generate a meme about itself. So everything nowadays can be solved as AI powered, or well, yeah. So we're missing the point essentially. So today we are witnessing a major shift in how engineering is done globally. The construction sector alone is projected to see AI adoption grow from 2.93 billion in 2023 at nearly 27% annually. Generative AI, which was once experimental, is now used by 75% of businesses and business investors that are actively demanding it generally nowadays. And it's seeing returns of about $3 for every $1 spent on investments. In South Africa, the wave is just beginning. Gauteng firms are already experimenting with AI for planning, and the South African AI Institute launched, which was in 2022, signals that government sees AI as the next tech frontier, which is good for a strategic national enabler. So the opportunity for civil engineers here is immense to adopt these tools for local needs and lead smarter infrastructure delivery. So let's dive right into it. I'm sure everybody nowadays is aware of ChatGPT and in some cases Cloud or Lima. These are considered large language models, not necessarily artificial intelligence. Large language models like ChatGPT, Lima, and Claudia are AI tools that generate human-like text and code. They don't replace engineers or humans, but they support us by summarizing regulations, draft documents and reports, exploring design options, and parse large text-rich information into a simple and simplified summary. To give you a good understanding of how large language models such as ChatGPT and any other ones work, I will play just a quick video.
What is Hitler plus Italy minus Germany?
One moment.
What is Hitler plus Italy minus Germany? This came up in a full video that I did dissecting what happens inside large language models. You see, when tools like ChatGPT process text, the first thing they do is subdivide it into little pieces, and they associate each piece with a large vector, some long list of numbers. This is called an embedding of that piece of text, and it's helpful to imagine these embedding vectors as directions in some very high-dimensional space, even if we struggle to concretely visualize anything more than 3 dimensions. Models that learn to embed words as vectors like this often encode meaning into the directions of this high-dimensional space. If you take the difference between the embeddings of man and woman, and you add that to the embedding of uncle, you get a vector very close to the embedding of aunt. If you take the embedding of Italy minus Germany, and you add it to the embedding of Hitler, you get something very close to the embedding of Mussolini. It's as if the model learned to associate some directions in this high-dimensional space with Italianness, and others with World War II Axis leaders.
Yeah, so this gives us just a quick overview of what goes on when we are talking about large language models and using large language models. But on the implementation of large language models and the way we do things, there are 4 major points that we need to keep in mind. We use them for information retrieval, document and reporting, idea generation, and communication. And when we drill down, we can see that for knowledge retrieval, we can use it to explain and summarize. We can use it to interact with standards and manuals. In terms of documenting and reporting, we can look at the initial drafting of paragraphs, sections, minuting. I know the minuting AIs or large language models that are currently being used are not necessarily the best, but they do assist us in many ways. In terms of communication, we use it to simplify technical languages, to assist with basic coding and scripting. And in terms of idea generation, we use it for brainstorming. So this is just a simple model of how they can safely be implemented in the way we do things. Now, going into engineering workflow automations. Engineering workflow automations uses technology to simplify or fully automate steps in engineering, lifecycle and design, construction, and assist in management of those assets. So thinking about think of it like replacing repetitive, time-intensive processes that take up that are converted into money as well. So this is a good example of what I'm trying to illustrate. So originally, let's say we have 3 tasks, and we know that in task 2 and in task 3 we have quite a few repetitive tasks that can be automated using engineering workflow automations, which might incorporate large language models or AIs. This directly translates into money made or money saved on the project, which can be converted into profit. When looking at engineering workflow automations, it can assist us in planning and design, construction and site management, operations and maintenance, or with the IoT sensors, predictive maintenance, autonomous equipment, AI-powered scheduling as well. In terms of planning and design, we're looking at BIM and generative design. Now, generative design has been globally adopted, but South Africa is slow to adopt this methodology just yet. So in my past experiences, traditionally, when we have solutions that we need to produce, especially at a high level or a master planning concept level, we can look at possibly using generative design on Revit or Rhino using Grasshopper, which utilizes genetic algorithms to be able to come up with the best solutions that can be given. So a good visual representation of the selection processes that it goes through is this is a really nice representation of a selection method for the best design that meets all the criteria, the input criteria that the engineers has. So this is how we usually implement automation and possibly some machine learning models on optimizing the work that we do and saving time, which can essentially has an impact on the amount of money or profit that the project makes. One of the most practical ways large language models are already transforming the engineering space is through documentation and compliance. So let's start with, let's say, reporting, right? Traditionally, compiling a design report, method statements, or any kind of summaries takes hours of writing and formatting, often under very tight deadlines. But now we can just, with a proper prompt engineering, an LLM can help us structure our first draft of those sections that we're working on, which we then take over as specialists and save time in our compiling of reportings. There's also code compliance. So as we know that within the engineering space, we use a lot of SANS and COLTO or municipal bylaws, which can be quite tedious to be able to parse and go through all of them and come up with the solution that we're coming up with. So large language models can help us summarize specific sections, for instance, like say from a civil engineering perspective, drainage requirements under SANS 2001, or even generate a checklist of checklist of tasks that will align us to TMH9, whatever the case might be. So we have to be able to use these tools in a proper way without having to impact our thinking or critical thinking capabilities as engineers as well. But they are extremely useful. So as you can see on the flowchart at the bottom, so AI design assistant it has the ability to rapidly and effectively generate numerous potential solutions, and it has the ability to automate many tedious engineering processing tasks, and has potential for designing more innovative solutions than those devised solely by human engineers by giving us more options to select from, not necessarily coming up with a solution on its own, but rather allowing us to iterate through more options as a result of us saving time. Um, yeah. So let's get on to the fun part of things. So here's one really cool implementation of integrating large language models into our engineering processing tasks. As engineers, well, especially in payment engineering, we have to work with traffic data sets, which we obtain in the form of PowerPoint, PDF files. Sometimes they can go up to a few hundred pages at a time when we have to go back, look at multiple traffic stations. We have to look at multiple years, which would be very tedious to go through each one, extract the data, put it into an Excel spreadsheet, process it, then compile the report. That is many, many hours of processing, many, many hours of specialized, skilled human being spending on it, which is billable. However, if we want it to be more optimized, we have to incorporate large language models and scripting. So this is what we've done. So the first layer, what you see here is, in this case, which I'm going to demonstrate, is we have 10 files which contain traffic data. All of them combined have about 160 pages to process through. They go through a layer of data parsing logic, which is stored in a Python script. And then once the data is parsed from the PDF, it is then sent to the OpenAI servers at the back end using an API call, which is then processed and parsed and then returned. And then the returned data is parsed and saved as a CSV file. To give you an understanding of this process, this flowchart goes through it in detail. So we have the PDF files. The PDF files, the text from the PDF files is extracted. It is sent to the OpenAI backend through an API call. The large language model then generates the traffic data table from the data that we have sent through the backend. And if we have a data validation section where we check if the data is valid. If it's not valid, then it is sent back to the large language model with a different prompt to process the data once more. And this whole process is automated. It's just a matter of clicking a button. And then once the data correction happens, it is then checked again for validation. If it is not valid, then it's left as blank. And if it is valid, it's saved straight to the CSV. And then this process is repeated for all the PDFs until we have one compiled PDF processed CSV. I will demonstrate this here in a video. So what you're going to see here is just the demonstration folder. This is just one of the tools that we have that we can demonstrate safely. The tool is now processing all the PDF files that are stored in our folders. So I'm just going to speed it forward just to give you an idea of how many files that it's processing. It's processing about 10 files. I'm going to speed it up a little bit. So these processes are very critical for our engineering tasks because they save us hours of work. So this would have taken more than 2 hours of time to do individually, manually. But the incorporation of these automation processes then allows us to be able to process this data within 3 minutes. So yeah, so within 3 minutes, the data is processed, 160 pages are parsed through, the data is extracted and saved into a CSV file, which we then take forward into our modeling. And the modeling task itself is also automated, but we're not presenting it right now. So in under 5 minutes, we have performed a task that would take us more than 2 hours. Now, what is the next step? Rather than just using GPT models, where is this going, and how do we incorporate it into our life, and how is it being incorporated into the industry? So nowadays there are large language model agents. There's quite a few papers that have been published, especially by Google recently, which proves that a cluster of weak large language models working together perform significantly better than the most expensive and the biggest large language model currently available for use. And the large language model agents that are currently in the market allows the users to perform many useful tasks. So large language models, the agent itself has access to tools such as, this is a good example of it, calendar tools, calculators, code interpreters, Google search, and many, many more. The ability to go to the internet, extract data, interact with PDF documentations, code, run code, host it, examine errors, and so on. It has the ability to store information into short-term memory and long-term memory, and then it actions, it plans based on the information that you're trying to extract from it. It plans for you, it criticizes itself, it has chain of thoughts, and then it actions things, and then this cycle is then repeated for whatever task that you want it to do. A good representation of this is imagine having
and lunch
a
spot
personal
found.
assistant that you don't necessarily have to repeat instructions to.
The week is planned.
Now, we have discussed all the fun and the useful aspect of utilizing large language models and AI into our workflows, but then there are risks associated to it. So recently there is a paper that has been published by a study performed at MIT, which looked at 3 groups of people to summarize the study, but you can read it at your own time. The 3 groups of people examined are people that are asked to perform an essay writing exercise, to write 3 essays. The first group of people only used their brain; they did not use any tools. They wrote the essay. Second group of people used search, which is Google, to be able to find information, and the third group of people used large language models such as ChatGPT. What we see here is in the first group of people, the interconnectedness, the areas of the brain that seem to be working together and forming connections is much higher. And as we go from group 1 to group 3, the interconnectedness essentially decreases. What this means is the improper use of large language models such as ChatGPT decreases our ability to critically analyze and think for ourselves. As engineers, this ability is very critical, so we have to be extremely careful about how we implement them into our lives. An illustration of what is happening and the impact of large language models into our life, improper use of large language models into our workflow is this chart shows it on the left-hand side here. The first line shows learning, and The second chart shows task difficulty. So over time, as we experience tasks that are quite difficult, the things that we end up learning also increase. Our ability to learn and the things we learn increase. Our knowledge base increases. Our expertise increases. And over time, our knowledge, we become more and more expert and more capable of learning things much easily. However, when we completely rely on large language models, not just completely, but when we start relying on large language models to do things that requires learning and understanding, especially if it's a topic that you have never had to touch on before, your learning decreases, it stagnates, your ability to learn and maintain information decreases. And over time, you no longer have the ability to go from being a beginner to an expert because you are stuck at a beginner stage, as we have essentially outsourced our brains. So if we outsource our thinking, if we outsource our brains, then what remains? So we have to be very, very aware of what we are doing to ourselves if we use things improperly, especially these large language models such as ChatGPT and so on. So we have to keep that in mind when we are talking about automation, when we are talking about AI as well. But bringing it back, proper use of large language models and AI into our workflow essentially allows us to have superpowers, to use them as an appendages to ourselves rather than a crutch that we rely on. If we do so, then we can use it for knowledge retrieval. We can use it to generate numerous potential solutions for us. We can use it to accelerate development, whether it's in programming or in our tasks. And then we can use it to save more time for us to do analytical thinking, which means we spend less time on admin. So with this, I'm going to leave you to ponder. I'll open the floor to discussion. Thank you.
Thank you so much, Dawit, for that insightful presentation. We will be moving on now to our discussion and question and answer session. Before we start that, I'm just going to answer a few questions here. Yes, the webinar today carries 0.15 CPD points for those who are inquiring, and the presentation will be available after this session. CISA will make that available to all. So if I can just dive straight into the questions and answers. Rozina, the first question is for you. And the question is from Chris Grunewald. How has your model been affected without an operational train system?
So I saw that question. I'm not exactly sure what he's referring to. If you could come off mute, maybe to.
I'm not sure if we can, Godfrey, if you can mute our guest, but I think it means the train systems were not in operation. So how did your model affect?
So at the time, the initial research that we did create a methodology that we put forward to PRASA on how they can basically implement a more proactive maintenance system. But at the end of the day, it's PRASA to implement that system. So we did the research, we compiled a report, we pushed it forward to PRASA, but it now sits with them because we don't have any operational influence within that space. So we did it as researchers within the University of Pretoria. I don't know if that answers his question.
Thank you, Rozina. Chris, I hope that answers your question. The next question is also to you, Rozina. Rozina, how do you confirm statistical reliability of information? Audio methods can be data intensive.
So we didn't use any audio methods, but yes, social media data can be quite data intensive and it's very noisy data. So what we did, obviously we cleaned up the data, we made sure that we validated the data. So there's a lot of manual processing in the back. So the beauty about the research that I did, I worked with the data science for social impact group at the University of Pretoria. So there are multiple researchers that were part of the work. So we did a lot of data cleaning, removing all the offensive languages within the data as well. It was quite intensive. And then in terms of the statistical significance, we pre-trained and fine-tuned the models that I mentioned before. I don't know if I could share my screen just to show you
Yes,
what I
go ahead,
mean.
please.
Yeah. So we had initially a training data set. So we had multiple training data sets which covered our different languages. So we fine-tuned our models on these data sets and got essentially baseline F1 scores that would essentially shows the reliability of using these models for the sentiment analysis. So for example, with Afro XLMR, we got a 0.97 F1 score. So that shows very high reliability in terms of using code mixed data. And then Afro LM with Setswana, which is 0.62. Not the best, but it just shows that we can fine tune the data. I mean, we can fine tune the model even more with more data that we can mine from social media or whatever. And then Afro XLMR for isiZulu was 0.82, so quite reliable. And then AfriBursa for Swahili, also needing more fine tuning. So this is a continuous process. It wasn't like the end of this, like this is not a once-off research. This is something that needs to be refined with time. But also to just validate the sentiment classifications that we got at the end of the day, we had to manually validate a portion of the predicted sentiments that the models gave us. So again, we were sitting with a team, there was 3 annotators. Each one of us could speak essentially the corresponding languages. So I validated on the Swahili. I had another person validate also on the Swahili, and then we used inter-annotator agreement to make sure that the model is actually giving us what we think it should be. So that's how we validated the results.
Thank you, Rozina. Rian, I hope that answered your question. Rozina, one more question for you before I move on to Dawit. Did your research include Gautrain?
No. So initially, when we were looking at platform train incidents, Gautrain only had one incident recorded, because the gap, if you've used a Gautrain before, that gap is almost insignificant. The problem with the gap happens within the metro rail system. So the issue is the metro rail system shares the system with the freight rail trains, which are much bigger trains. So stations have to make provision for that space. So you find that now the passenger train is much thinner, or much, so the gap between the platform and the train becomes much wider. So Gautrain doesn't have that issue. It's an isolated system, so they can make that gap completely insignificant. So no, we did not consider Gautrain.
All right. Thank you, Rozina. And now to you, Dawit. A question from Greg Tucker. Have you found a model that can interpret detailed graphical modes of documentation, such as drawing and Gantt charts?
Yeah, thank you. Thank you for the question. So when it comes to graphical interpretations, the current, my apologies, my computer is not plugged in properly. The current models that are currently available on the paid versions of the OpenAI models, generally even the Gemini models itself, have the ability to interpret Gantt charts and flow charts and so on. However, when it comes to technical, detailed drawings, it might be a bit more technical for it to be able to understand the full context of things. In small sections, in small snippets, it has the ability to understand it. So yeah, it depends on the task that you're trying to accomplish. If you wanted to give it a complete PDF image drawing of your model into a large language model, I don't think it has the ability to fully understand the context of it. However, if you were to feed it flowcharts, if you were to give it Gantt charts as an image into the chat itself, yes, it can interpret it for you. Yes. One moment, let me just plug my laptop in properly.
Okay, we'll just wait for Dawit to return. I'm just going to see if I have any more questions for Rozina. Rozina, what advice would you give to young engineers interested in bridging the gap between civil engineering and data science?
What advice? Wow, this is a tricky one. So what I wish I heard at the time when I was branching into data science, I think the trick is to always to remain a student. This sounds very cliche, but you need to almost live a lifestyle where you're always open to learning something new, and also shift your mindset to almost always thinking of ways to make things better, or ways to make your work more efficient, ways to save yourself more time. So at any point, if you feel like you're getting complacent, then that is a problem. Like, dive into a new problem to solve. So I think that way you'll always be hunting for new tools that can essentially improve the way you work. And by improving the way you work, that's how you, I guess, create a reputation for yourself. And you'll essentially get more work that will challenge you more. And it becomes almost like a cycle, you know? So you just have to create an environment where you're always open to learning new things and chasing new problems to solve. That's the only advice I can give.
Thank you. And moving right along to Dawit. Dawit, how should engineering firms approach the adoption of AI tools while maintaining professional standards and accountability?
That's a really good question. In most of the international spaces that I have operated in, especially when the introduction of AI started happening, the biggest concern was security and information security, and feeding client data to a large language model, which might then be reused later on in life. That concern is real, and it's something that it should be taken into account. And the solutions that most large organizations are adopting to be able to avoid the issue of information security is the incorporation of local large language models, which are operating within the organization itself, hosted by the organization itself. So the likes of Llama, which is a large language model that is freely available, I believe is developed by Meta, is mostly used for a local large language model, which is essentially used only within the company itself to be able to parse documents, reports, and have like an itinerary of information that it has the ability to go in and extract information from. So that will solve the information security aspect of things. In my opinion, I do believe information security is very, very critical, and it's very important for us to practice the appropriate standards. But it's not something that I think might make too much of a difference if you were to ask ChatGPT question of using maybe something that might be a bit sensitive. But yeah, at the end of the day, we do have to practice standard information security practices as well. Yeah.
Thank you, Dawit. I have a question for both speakers from Pravanya. She says, thank you for showcasing practical examples of how AI is used in your work. I'd like to check from a business perspective, what policies and protocols are in place with regards to using AI in terms of technical work? And are there any limitations or cautions to company-specific info that is used in the prompts or training? So I'll allow you, Dawit, to answer first, and then Rozina, you can follow.
Sorry. Yeah, so if you were to further train a large language model, you would want to do it in a controlled environment using an open source large language model, such as the Llama, like I mentioned earlier, right? Or there are many other ones actually, but the ones that I like to use is the Llama models because they are quite developed and there's a lot of documentations around them. So prompt engineering is very important. I'm still trying to grasp the question a little bit, but when training, the training data has to be structured in a way that that the model can develop from it. I think Rozina might be a bit more of the best person to answer this question as well.
Yeah, so in terms of limitations, if I think back to when we were training our models, with the data we had, it had personal information. So you've got user information that you first have to clean out. So that's part of the processing that we had to do to ensure security, essentially. And also, I've worked at a bank before, and now I'm working in a law firm, essentially. So there's masking ways where you can ensure that sensitive information isn't going into the model. So, and also, like you said, it has to be in a controlled environment. So you find a lot of organizations buy these tools, but they structure it in the architecture of that specific company to make sure that no personal information is getting fed back to OpenAI, for example. So it's definitely something you have to take into consideration, like what type of data are actually feeding into these models. So definitely a massive pre-processing step is making sure you're not sharing sensitive information. Yep.
Thanks, Rozina. One more for Dawit. What are the implications of feeding an AI model your client's data to solve problems without risking copyright issues?
Yeah, that is the issue. Copyright is the biggest problem that you would probably face if that data that you're using to chat with it or used to maybe parse information from is then used to further train that model, and that information is copyrighted and is risk to IP loss, then yeah, you're facing that risk. And that is why what we just mentioned is very important. If you are very concerned about that, and if you want to comply to the international standards, especially when it comes to working with international clients, data sensitive clients, such as banking industry or the finance industry, it is very important that you have your own infrastructure, large language model infrastructure. So companies like BMW, I know, have implemented their own large language model infrastructure. Companies, banks such as Standard Bank have also implemented that into their own infrastructure as well. Azure and AWS frameworks, I mean, cloud frameworks also offer that opportunity to be able to build that in for yourself. And if you don't really want to go down the software development path, then you could use the Microsoft Copilot's SharePoint integration, and you would have the large language model integrated into your workflow with the data security maintained as well. So what is that essentially allows you to do is you have a repository of information within your company, which is stored within SharePoint, and Copilot has access to that data, which is stored in the SharePoint, and you have the ability to interact with years and years and years of information that you have stored, reportings, drawings, and it can parse the data, the text from the drawings, and might not necessarily understand the full context of it. But what I'm trying to say is it is more controlled, the IP is maintained, and there is no data leak.
Thank you, Dawit. We have a comment from Kavani Mabusela, says, beautiful advice, Rozina. Thank you very much. And then I will allow Rozina to take the next question. So please comment or relate to us on any experiences that you might have encountered with respect to data decay that you may have experienced when using AI for any applications.
So I saw that question. I'm not exactly sure data decay in what context. I don't know if Dawit, you actually have. Yeah, I wish.
Okay, maybe Ellen, you can rephrase the question. I'll move on to the next question for now.
Oh, maybe if I could mention,
yeah.
I think I've just looked it up. She might be referring to data degradation over time, so gradual loss of data quality over time. That's what it says. So, I mean, that's the only time you'll be concerned about that is if you're storing your stuff still in floppy disks and CD drivers, right?
Yeah.
Even hard drives have a lifetime of about 10 years, right? 10 years, the polarity goes away. But right now, if you're using cloud infrastructure like the Google Drives, the SharePoints, the Dropboxes, then I don't think you would have to worry about data decay in that way. But yeah, I don't know. Maybe if she can give us more context, we can answer that.
So another way I can think of data decay in the context of maybe transport engineering is almost like how relevant is your data now that you collected previously. So maybe I haven't experienced that yet because we're still in the 5-year cycle, essentially. I think within transport, we take it in almost like 5-year blocks. So I can't use data from like 5 or 10 years ago to develop solutions now. So it's almost like you always have to be updating your data constantly. Yeah. You
so
always
Alan,
have to
you can drop us a comment if that answered your questions. Then we'll move on to lithium. This question is for Dawit. Dawit, would you recommend that we use our brain 100% rather than using the AI as a tool? Because I feel saying we should use it as a tool is very subjective, and it can be challenging to draw a line between abuse ChatGPT and using it to help you complete a task. And he says, I hope my question makes sense. How can we self-check to ensure that we are not abusing AI?
Yeah. I think one of the tests that I like to do for myself to be able to see if I have crossed the line is to try to write an essay once in a while by myself. And then that will be a very good indication of whether or not you're heavily relying on it. But coming back to the topic a little bit, aside from the satire, we cannot be left behind. Whether we like it or not, technology is going to come. Technology is here. It is the future. It will be integrated. Whether you are going to use it or you don't use it, it is going to be incorporated into the way we work. Now, the question you have to ask yourself is, how can I safely do that without having a negative side effect on myself or my ability to provide solutions to the problems? Now, that is where your critical thinking comes through. And you say, okay, I can use this stick to carve a path in the meadows, or I can use it as a crutch to walk up a hill. So, I mean, if you're using anything as a crutch, it becomes a problem. But if you use it as a tool, like you use it properly as it should be, then it's not an impediment, but rather it accelerates your advancement. It accelerates your learning. It gives you access to information that you don't necessarily have easy access to. It speeds up your ability to obtain information, process it, and retain it. Now, if you use it blindly, you are very irresponsible and you are damaging yourself and your ability to think as well. So I think that is I think that paints a good picture of what I've been trying to communicate as well.
Thank you, Dawit. I'll move to the next question for Rozina. What are some of the biggest challenges that you faced when applying data science in civil engineering context, and how do you overcome them?
So I think the biggest challenge when it comes to data science, I don't even think it's just a civil engineering context problem, but it's access to data. So it's your tools can only help you as much as your data, basically the quality of your data. So when we were conducting this commuter sentiment research, access to data was our biggest thing, because using social media data is great, but now we were mining data at the time when Elon Musk took over Twitter and he shut down completely any access to Twitter. So that was a major setback in terms of us sourcing data. So we had to find other alternatives. And the biggest challenge was essentially getting access to the data to the other alternatives. So how we try to overcome this is basically to build relationships with the owners of that data and make sure that we can source this data in an ethical way. So the biggest challenge, I think, with any data science problem, with any data science project, is how do you get the data you need and how do you actually source it ethically? And that's where building relationships with other disciplines comes into play. So we can't work in isolation ever. So it's always it has to be a symbiotic relationship between the people that you are sourcing data from and the people who you're trying to solve the problem for. So I don't know if it's a challenge I've overcome, but I don't even think it's a challenge to overcome. It's almost like we just have to evolve the way we work and make sure that we bring in a lot more disciplines into our projects and create more relationships with other fields so that we can, I guess, create a beautiful pipeline of how we use the data. Yeah.
Thanks, Rozina, for that honest answer.
Sure.
A question from Santosh Prem. Hi, Santosh. I'll give this one to you, Rozina. Something more mundane but causes major problems for most design consultants. Can AI be trained to check the correctness of drawings and documents that are produced from design calculations?
That sounds more like a David question, but just thinking about it, I think with like your computer vision models, I think you could train a model to, I'm reaching right now, but
Okay,
in my head,
I'll ask
I'm
Dawit to
thinking
elaborate. Dawit can elaborate first.
in
Yeah,
theory,
like
I think it
if
works.
you are really stuck on using the drawings to check correctness
Yeah.
in the drawings, then computer vision models are obviously the best ones, in collaboration with OCR. However, if you really want to look into the engineering aspect of things and making sure that the information represented on the drawing is correct, then it has to be the incorporation of machine learning models, engineering workflow automations into our BIM infrastructure, which then has an impact on our 3D models and the information that we are putting into our models, which then we have to check with the federated model, clash detection. One of the tools that I've worked on before was clash avoidance tools implemented within the Revit infrastructure. So yeah, so that is how you ensure that the information that you have in the drawings is correct without having to go down and up a mountain and go around the corner using the computer vision and the OCRs rather than just like making sure that the pipeline in front is correct, then you make sure the drawing in front that comes afterwards is also right. Yeah.
While we're on that question, Dawit, I'll go to the next one, which says, are there any AI tools available to present a 3D model of a structure using 2D drawing from CAD?
Yeah, there are tools that are in development, but I haven't used any like that. Hey, there are CAD-aware or CAD-aware tools, CAD-aware machine learning models that make use of computer vision models that essentially have the ability to look at the full drawing, especially very simplified. Those grade 12 TD drawings, those isometric top view, side view. They have the ability to look at that and generate the 3D model from scratch. However, if you already have a 3D model and you have tagged your drawing with a QR scanner, you can utilize augmented reality to view your drawing in 3D just by panning the camera over the drawing itself. Yeah. Yeah. So
All right.
there are methods. There's no one tool that rules them all.
Okay, Dawit, I have another question for you. What are
Yes.
the limitations of current AI tools in engineering, and how can professionals work around them?
One of the biggest limitations that we're facing in engineering, especially in the incorporation of large language models, machine learning models, and some so-called AI models or tools, is our knowledge of it. And the technical knowledge has not necessarily increased over time within our civil engineering space, especially in South Africa, especially within the information technology and in the integration of those two spaces. So the biggest hurdle we would face is not necessarily the lack of technology, but rather our knowledge of how to develop and use that technology. If we have those tools, those skills, those basic data science skills, such as your ability to write Python codes, your ability to process CSV files using Python and pandas and all those fun languages, not really languages, but libraries, then it brings you a step closer to really understand the space and really incorporate it in your life and incorporate it into the engineering space more efficiently. So what I would say, something that has made a huge difference in my life and has allowed me to do things that I could have only dreamt about, especially when it comes to the computer programming space, is my ability to write code and understand it and make softwares, platforms. It opens a lot of doors. So it starts off with the Python, starts off with the basic data science and data carpentry. Then you move on to the development of the software engineering development side of things. If you have that ability, then you can merge those two spaces. You know the gaps. You can see I have a list of things that I write down on a daily basis that are a headache to myself, and I try to automate it. My partner said, you have to want to improve the space that you operate within, selfishly for yourself. so that you don't spend a lot of time repeating tasks. That's how I would say we can incorporate these tools into our space. There's no one tool where you type in a question and it gives you a solution. It's all the tools that we need is out there. We just need to know how to wield that axe. We just need to know how to use that hammer. We need to know how to recognize what what one tool is from the other and how it can be used correctly. So that's what I'm saying. Maybe increasing our technical knowledge around this space is the most important part of it.
Thank you, Dawit. I'm going to give this next question to Rozina, purely because I have another question for Dawit. So Rozina, I think based on your research, Clayton would like to know whether you think the Bureau of Standards in South Africa is prepared for AI, which is a reality. Do you think there are any plans for standardization?
So I don't know if we're ready, but I think we can work on it. So a lot of these AI tools have been designed from an American context. So there'll be a lot of fine tuning that we have to do for it to match the South African context, but we need to be proactive about it. We need to be intentional about it. So I'm not aware of any work that the Bureau of Standards is actually doing, but there is potential. Like, it's possible to fine tune these tools to match the South African context. There just has to be a willingness to do it or an intention to do it of the powers that be. I'm not sure if they're actually working towards it. But
Thanks,
yes,
Rozina. Clayton, I hope that answered your query. And then to you, then I'll move on to Dawit. Dawit, since we can't ignore the rapid growth of technology usage or reliance, how soon can AI be introduced or accepted in schools for research, assignments, and projects? And will this do away with solving problems from first principle?
Yeah, I find it very difficult to hear when my brothers tell me that they're using ChatGPT and so on. It's like wrenches my stomach. It's a very scary thing. The skills that we need to be learning to be able to use these tools is how do we prompt them? How do they think? How is the information stored? How is the information processed? If we can teach those skills, then when those individuals have already gone through the first principle understanding of things, not just from the technical and the AI side of things, but first principle maths, physics, all those things, right? They're very important and we cannot run away from it. Even the ability to read and write English, that is going to be taken away from us. Our literacy is going to be taken away from us. It's a very scary, it's like we're playing with fire, right?
Yeah.
But it has immense potential. Fire can cook food for us, So to answer that question, I mean, I wouldn't introduce AI into the schooling space. I would do it very carefully. I don't know how it can be done so, but first principle is very important, not just from the schooling, but to our profession as well as engineers. We have to, not just as engineers, as problem solvers, we have to think critically from first principle always. And we use tools when they are necessary and if they are useful.
Yeah.
All right. Thank you very much, Dawit, for that. I'm not seeing any more questions on the chat box. See here, Adrian says, very informative and something to think about. Thank you to our speakers. There's a lot of thank yous in our chat box, but essentially, thank you very much. For those who are inquiring about our speakers' details, I think please get in touch with Godfrey at CISA, and he can forward the relative information to you. Last one from Ellen. Ellen says, thank you very much to both Rozina and Dawit for the most excellent and most informative presentations, and Amanda for organizing and hosting. Thank you very much, everyone. If there are no more questions and answers, just allow me to close. Thank you once again for joining us today on this session on AI. We've explored artificial intelligence and how it's reshaping our industry from our predictive maintenance, design optimization, automation, reporting, data-driven decision-making, and so much more. Our speakers have highlighted opportunities and the challenges that come with integrating AI to the real-world applications. So as we move forward, it's clear that embracing AI is not just about adopting new technology, but it's about evolving our thinking, our systems, and our collaborations across all disciplines. So we encourage you to continue the conversation, to explore new solutions, and to consider how AI can enhance your own projects and professional practice. Thank you once again for joining, and we look forward to seeing your innovations and what you'll bring further into the engineering field. And from myself, Amanda, and the team at CISA, thank you very much. And thank you to our speakers. Goodbye.
Thank you as well.
Thank you all. Cheers.